I spent half my life on security. I left White Flint yesterday, 4:07. I've been out there since 1 o'clock.
Okay, let's get started. Let me have your attention, please. Let's get started. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker. But before I introduce today's speaker, I want to put on my student recruiting hat. This past the Christmas holidays, I visited new family members out west, and I met a young girl whom I describe as a child prodigy. She is incredibly bright and articulate and intelligent, way beyond her years. And so whenever I meet a young person like that, I put on my recruiting hat for the Nuclear Engineering Department. And so this young girl is not even a teenager yet, but I've gotten her excited about nuclear engineering at the University of Tennessee. And I told her during the holidays that at one point during our colloquium program that I would say hello to her. And her name is Emma. And so, Emma, hello. We hope to see you as a volunteer in several years in the future. Okay. Now for today's speaker, who is Mr. Marvin Fertel. He is the Senior Vice President and Chief Nuclear Officer for the Nuclear Energy Institute. And the main offices are in Washington, D.C. Marvin received a B.S. in Civil Engineering from Northeastern University in 1968, an M.S. in Environmental Engineering from the Polytechnical Institute of New York in 1971, and then from 71 to about 1990, he was a power industry consultant, consulting for both fossil and nuclear power plants. Since 1990, he's been at the Nuclear Energy Institute, or its predecessor. And so we are indeed privileged to have him with us today. Ladies and gentlemen, please welcome Marvin Fertel.
And it's a pleasure to be here, and if Emma is listening, I'm going to talk about some future opportunities in the nuclear industry. And even though I understand she's only 7, I think those opportunities may be just right for her as she grows up. Let me take 2 seconds on what the Nuclear Energy Institute is for those that don't know. It's the policy organization for the nuclear industry in our country particularly, even though we probably have about 115 international members. All of the companies that operate nuclear power plants or supply nuclear power plants with fuel or other services are members of NEI. And one of the major things that we do and that I spend a lot of my time on is dealing with the Nuclear Regulatory Commission on issues, technical and regulatory issues that are generic to operating our plants safely and reliably. And if you have any questions on those things, we can talk about them as we go forward. I'm going to focus today on where we see the industry going. I'm going to end and talk a little bit outside of energy and the other things that go on with nuclear materials, which have tremendous benefits to society. And I think the thing I'd like to say to the young people, both in this audience and listening in cyberspace, is that working with nuclear technology and nuclear materials offers a tremendous opportunity to benefit society. And if you really dig in and learn about it, you'll find that you can contribute tremendously to improving the quality of life of people, not only in our country, but worldwide. And that's a really good thing to do. Okay, it's not just a technology thing. It's not just doing good engineering and doing good science. It's actually contributing to bettering the lives of people that live on this earth. And that's something I'd really encourage people that are listening to think about as they go forward. I'm going to talk about a few areas. Now, I understand Dan Kiter from Entergy was here 2 weeks ago, and Danny steals a lot of the slides that we use at NEI on general industry stuff. And Danny may even have said that if I were smart enough, I would have looked at his presentation and skipped over those real quick. But I will talk some idea on the industry performance. I'm also going to talk about some long-term industry initiatives I must talk about managing used fuel because everybody's always interested in what do you do with the waste. I'll talk about where we see new plants going and why they're necessary, and I'll end with some discussion on what we think is strong public and policymaker support for nuclear energy. In talking outstanding performance, there's three really important things that we look at from an industry standpoint, and number one, it's probably number 1, 2, and 3, but the other two still count, is safety. Okay, we have to operate our facilities safely, and not just marginally safely, very safely. And basically 11 days from now is going to be the 25th anniversary of the 3 Mile Island accident in our country, which was the most severe accident our country has ever seen. Though no one was hurt by TMI. Okay, there was no injuries that we haven't done, but the state has done, the federal government has done numerous studies, and there has been no damage to anybody as a result of the very little bit of radiation that was released. There was a lot of trauma. I want to take a minute on TMI because it changed our industry dramatically, and it changed it much for the better. The belief when I was probably the age of a lot of the people in this room and some of those on the webcast was that defense in depth, the way we designed our facilities, protected our facilities and protected the public from any sort of an accident. And to be honest, TMI showed that there was a lot of truth to that. The reason nobody was hurt was defense in depth work from a technology standpoint. But what we didn't pay enough attention to was operational safety. We didn't pay enough attention to the human aspects. We paid a lot of attention to the physical plant aspects, the systems aspects. And as a result of TMI, reactors are dramatically safer everywhere in the world, certainly in our country, but everywhere in the world. Because operational safety now has the same standing as technology and defense in depth and physical facilities. As a result of TMI, we made dramatic changes in how we train our folks. At a nuclear power plant now, and if you haven't visited one, I'd encourage you to do that. If you talk to operations staff, they spend more time in simulators than airplane pilots do. Okay, they spend more time in simulators than airplane pilots do. There's always a shift in a simulator, training. We went away from an approach that we used in proceduralizing things, which we thought we could identify the types of accidents, and therefore the operator would know it's accident type A and implement procedure for that. Well, we decided that's not smart, because you don't know what caused the accident. So you dealt with it like a doctor does. You deal with symptoms, what's happening to pressure and temperature. And we made our operators a lot smarter, so that they understood the fundamentals, so that they could deal with that, and when they figured out and stabilized the reactor, they could then move on and fix whatever caused it. But the first thing was to stabilize the reactor like you'd like to stabilize a patient if you were a doctor. We created a whole new emergency preparedness regime around our facilities. It's the best in the world. It's also really used regularly for natural emergencies, hurricanes, storms. Okay, it's not used for nuclear emergencies because we haven't had any. Okay, we exercise it, but we haven't had to actually implement it. But it does get implemented around a lot of the plants when you have a natural emergency, hurricanes and things like that. We also went down the road and created a bunch of industry organizations, the most important of which is the Institute of Nuclear Power Operations, which is in Atlanta. And INPO's role was to set up an accreditation program for accrediting training programs at power plants, for maintenance workers, for operators, for others. The other thing that INPO does is they strive for excellence at our plants. Not mediocrity, not regulatory requirements, but excellence. If Danny was here, he'd probably say sometimes they push too hard because excellence in INPO's lingo doesn't include cost. It's just how do you do it better. Okay, so a lot came out of TMI. You're going to probably hear quite a bit about 3 Mile Island over the next couple of weeks because of the 25th anniversary. And I think the message I'd like to leave the audience with is that it was an event that shouldn't have happened. It was an event that a lot of people learned from. It was an event that ended up making reactors everywhere much, much safer post-TMI than they were before TMI. But it's not the way we should actually learn about it. Let me quickly take you through some of what I'd like to say on the performance. I'm sure Danny showed this slide, but I think the important thing you need to know about at least the U.S., I'm going to be somewhat U.S.-centric, so if there's questions about the international nuclear situation, please ask them at the end, because I'm sort of focusing in on our country right now. The thing that makes our electricity system as good as it is diversity of supply and diversity of technology. We would not advocate at the Nuclear Energy Institute, we only have nuclear power. We would advocate that the strength of the system is different sources of fuel and different technologies. Now, nuclear energy is our second largest source of electricity following coal. It's really important from that standpoint because each one of these sources have their own positives and negatives and attributes. One of the problems we have in our country right now is that for the last 5 years, about 95% of everything built was gas. That's because gas prices were inexpensive. That's natural gas, not gasoline for your cars. And it was down around $2 per million BTUs. It's now up, at least for utilities, in the $5 to $6 range. That's a very dramatic change because from an electricity standpoint for a gas plant, the gas price is about 90% of the cost of electricity. So if I triple the price of gas, I'm tripling the cost of electricity to the customer. It is almost a one-to-one ratio because gas drives the cost from the plant because the capital costs are lower. That's a real issue. Let me put that a little bit in perspective. We had a discussion at lunch today about the use of certain resources like natural gas. If you were, typical nuclear plant's about 1,000 megawatts, million kilowatts. If you basically took a 1,000 megawatt gas plant and produced the same amount of electricity you do from a nuclear plant, which means it would operate about 90% of the time, 24 hours a day, 365 days a year, you would basically use as much gas as you would use to heat 660,000 residential homes. 660,000, that's 1% of all the residential homes in the United States. So if I actually had 100,000 megawatts, which is about what we have in nuclear energy in this country, I basically would use as much gas as we currently use to heat your homes. Now, that would drive your home heating costs way up because supply-demand works. If there's more demand, supply isn't catching up, which it's not, cost goes up. So using what we have in diversity is important. We would advocate more nuclear is important. We would actually advocate you got to use more coal because the nation has a lot of coal, but you got to burn it cleanly. One of the things you commonly hear is, and it's true, is that France uses more nuclear electricity, more nuclear provide electricity than we do. France gets about 80% of their electricity from nuclear power. But nobody has a bigger, and to be honest, a better program than our country. Our country, and this is kilowatt hours. Our country produces more than France and Japan, which are the two next largest producers of electricity, combined in kilowatt hours, which is what turns the lights on, makes the air conditioning work, keeps us all comfortable, makes quality of life better. And that's something that's not recognized. The other thing is, I'll do what Lee suggested. If I come over here and I circle this number, that's 780 billion kilowatt hours. That's how much electricity we produce in the United States with nuclear. That's more electricity than is used in all but 3 countries in the world. Not nuclear electricity, total electricity. Japan, Russia, and China actually use more electricity than 780 billion. No other country does. So the U.S. nuclear program could supply the rest of the world, individual countries, and have leftover electricity. It's a very, very large program. And my point is that when you hear our program isn't the biggest, it is the biggest. It's just we use a lot of electricity in our country, and we're blessed with an abundance of other resources, so we can actually use coal and other things much easier. One of the measures of performance, and I'm sure this has been presented to you before, is what we call capacity factor, which is how many hours am I producing electricity out of a year versus the total I could be. For a nuclear plant, you have to refuel. Our plants generally are on an 18-month refueling cycle. So about every 18 months, we go in and replace about a third of the reactor core. So you do have to shut down to refuel. What we've seen is sustained performance by our industry on capacity factor. Now, that's not a measure of safety, but what we found is our most reliable plants are also our safest plants, and it kind of makes sense logically when you think about it. If you're operating well, you probably don't have safety problems. If you're shut down, you probably have something going wrong that's created some problems with you. So we're pleased with the sustained performance, and we expect it'll continue. To put in perspective, those are fleet numbers that we have here, about 89.6% in the year 2000. To put that in perspective, if I looked at it, and we have 103 plants, if I took the top quartile, 26 or so plants, they're at about 97% on a 3-year rolling average. If I look at a 3-year rolling average, I pick up refueling outages. So our top quartile is actually performing at about a 97% capacity factor, which is extraordinary. It's the best in the world. Our worst quartile is down around 83%, which 10 years ago would have been our top quartile. So the fourth quartile isn't all that bad, and the people in engineering and take any math, everybody can't fit in the first quartile, but what you're going to see is everybody move that way. Because you can do it now, you're not changing the plants, you can manage much more efficiently. One of the things we find is that nuclear plants really are the cheapest producers on the margin, and the numbers that we use for that are what we call production cost. And production cost is not an all-in cost. It's the operations, it's the maintenance, it's the fuel cost. For nuclear plants, it includes decommissioning and waste disposal. What it doesn't include is capital that I spent to build my plant for going forward capital. And we can talk about questions on that later because it's a little complex on how capital gets dealt with. But if you looked at a merchant nuclear plant and you said, what is the going forward capital and other costs, you might add 0.3 to 0.5 of a cent to the 1.7 cents there. So it might get up to around 2 cents or 2.2. It's a very, very economical form of generating electricity once you deal with the initial capital structure of putting the plant in place. What you can see here is oil and gas are much more expensive because the fuel costs drive it. We don't burn much oil in our country anymore. We'll burn more oil if gas prices stay high, except that right now oil prices are also about $37 a barrel, so they're pretty high too. One of the things that we're doing, there's sort of a three-step activity going on in the nuclear industry right now to help our country meet its energy demands and do it in as environmentally benign way as possible. What we're doing is we're uprating our plants. Okay, when I got a license for my plant, I was told I could operate it at 1,000 megawatts. I can now go in and I can operate it by taking advantage of new technology, maybe changing out turbines to more efficient turbines, which would be a significant effort. Or sometimes I can get a 2 to 4% increase because I've got better instrumentation, which allows the Nuclear Regulatory Commission to have greater confidence in safety margins. So I can operate at a higher temperature because I have better instrumentation. So what we're seeing across the industry are the companies making decisions to uprate. And in the last few years, we added 2,000 megawatts, which is like 2 large nuclear plants, to our current fleet. We think there's another 2,000 that's going to come in over the next few years based upon what's been filed with the NRC. And of course, Browns Ferry is moving forward to basically get completed and restarted, and that would bring on about another 1,300 megawatts in the next 3 years also. So there is additional nuclear capacity coming on in our country. It's just not in new physical assets. It's in uprating or completing. Dan Kiter may have shown you this one. We think it's a really it's a good news story. The bad news story on this is why weren't we performing much better in the late 80s and early 90s? Okay, and that's an issue that I think people have learned from. Some of that was PMI and a lot of retrofits that were going on, and there were other things. But fundamentally, since 1990, the improved output from the plants, plus the addition of a couple of new plants, has resulted in adding the equivalent of 26,000 megawatts to the grid. So it's like you built 26 new nuclear plants since 1990 in our country. And that's one of the reasons we as a nation haven't had to build a lot of new capacity as far as baseload capacity. And one of the things I should mention is nuclear plants, like large coal plants, but nuclear plants even more so, operate ideally 24/7, 365 days a year. You don't cycle them. Those low production costs I showed, that's what you'd like to do. You'd like to keep those low production costs out on the grid. So what you're trying to do is operate these plants as much as you can. You have two other types of capacities on an electricity grid. You have intermediate, which sort of cycles and maybe has a capacity factor not of 90 or 100%, but somewhere in the 40 to 60%. Then you have peaking plants, which are usually gas combustion turbines, and they may only have a capacity factor in a year of 2%. They only come on the hottest days of the year or the coldest days, depending upon how electricity is used in that particular region. The other thing we're doing is nuclear plants have a 40-year license from the Nuclear Regulatory Commission. The basis for the 40-year license had very little to do with technology. When they passed the Atomic Energy Act, you were getting FCC licenses for 40 years. It seemed like a reasonable period of time for amortizing things. So they decided the 40-year license was right. How that conveyed itself into technology was the Nuclear Regulatory Commission, their predecessor, the Atomic Energy Commission, made you do your analysis on a 40-year operating cycle. So they approved your plant based upon looking at the equipment on a 40-year operating cycle. but it wasn't a pre-thought out thing that 40 years was, at the end of that period, the plant can't operate. It was, let's analyze for that period and make sure that you can safely operate during that period. Most of a nuclear plant gets changed out, anything that's moving. All the moving parts are in a either predictive, preventive, or corrective maintenance program. You'd usually do predictive and preventive because you don't want it to break, but if it's not important to safety and it doesn't affect you much on reliability, it can break. You'll go in and fix it, replace it. So a lot of the plant is taken care of in programs. What you can do with the Nuclear Regulatory Commission is renew your license for 20 years. You can renew it for another 20 years after that. There's no limitation on that. Right now, the NRC has reviewed a number of licenses. You can see that 23 are granted. If you look at all the numbers on this slide, you'd see that more than 50% of the industry has either gotten into the process or announced they're going to get in because they want to get in the queue. NRC is trying to plan their resource allocation, so they've asked the industry to kind of give them a look ahead. So if you want to come in, they want to plan for the review cycle because it's about a 2-year review cycle. Our expectation right now is that all plants will probably go for license renewal. I'm going to turn now to some of the long-term industry activities that I thought would be useful to talk to you about. And these are the ones I'm going to start with. I'm going to start with the material performance. We're talking about plants operating for a long time. You have a lot of issues with making sure that the material, physical part of your structure, operates as well as it can, and you don't have corrosion, you don't have other failures. And we've had some experience that is not good, that we had to learn from and we have to fix. Nuclear plant security was always important. It's certainly more important since 9/11. We see environmental issues, I would say actually benefits as a big important aspect of nuclear and something we should touch on. I'm going to certainly talk about used fuel management, and we'll touch on new plants a little bit. On materials, when you think about it, you've got a nuclear plant. For the engineers that are on the webcast or in the room, you obviously know what's going on in a nuclear plant. You've got a lot of water circulating. You've got a lot of radiation in certain areas. You've got a lot of chemistry going on, and you're dealing with materials that can corrode in some cases. So what we've got at the plants is we thought we had, in all areas, a very good material management program. And in some areas, that's proven true. In other areas, it's proven us wrong. We had a bad experience 2 years ago with the Davis-Besse facility where they had very bad corrosion on their reactor head. Now, they were in a program that should have found that. The breakdown was not the program. The breakdown was the implementation of the program. It wasn't that corrosion of reactor heads was unknown. We knew about it. It could happen. If you got boron in the vessel, if you had any pathway for it to get on carbon steel, you get boric acid out there. Boric acid eats carbon steel. Okay, so it wasn't a very difficult phenomena for the people to understand, and you had to manage it well. They didn't. But the Davis-Besse experience actually forced us as an industry to take a much harder look at the whole material management program. And that's been very valuable. We spent, before Davis-Besse, and we still do probably, about $60 million a year on materials-related R&D, looking at how do you understand the phenomena, how do you fix it if it happens, how do you prevent it. And we now are not only spending that $60 million, but we're looking at this in a much more integrated way. All these programs, basically on their own, were pretty good programs. It's like getting a bunch of students to take an area and go off on their own and figure out what they might want to do in R&D or in analysis. Probably would do a better job if you all sat down and talked about that area and figured out how to integrate what each one of you thought was a good idea and come up with a program that you made sure the priorities were the highest priorities, getting the most resources first. That's kind of what came out of our review. And we're in the process now of basically looking at materials in a much more integrated way from what are we doing? What are the highest probability problems we may have? Do we understand them well enough that we can prevent them? If we can't prevent them, are we prepared to deal with them from a fixed standpoint when they occur? Do we have the right testing and analysis capabilities? Do we have the right materials we're looking at? And that's a pretty significant effort. I mentioned $60 million. We also asked the industry to basically create a fund of another $12 million for this year and next year for us to be able to allocate to higher priority things that weren't getting the attention that we now think they should. Next week when I'm in Washington, we'll have a meeting of what we call the Materials Executive Oversight Group. They're going to spend probably 12 hours with every one of the programs coming in, presenting what they're doing, to see whether or not they've got the right focus, to see whether or not they've thought through it, and to see how it's integrated with what the other programs are doing. So this was an experience at Davis-Besse that was certainly not good for Davis-Besse or First Energy. Again, I think from an industry standpoint, it was actually a positive experience for us to do something better out of it. Shouldn't have happened, but you got to make the most of what you got. Nuclear plant security. Prior to 9/11, obviously you had security at nuclear power plants. You've always had security at nuclear power plants, and it was always pretty robust. It was geared towards preventing radiological sabotage. Okay, there aren't things you'd steal at a nuclear plant that helps you make weapons, or even, to be honest with you, people talk about stealing spent fuel. You can't walk off with spent fuel. Okay, it's real hard to create an RDD out of stuff you'll find in a nuclear plant. Okay, so it was really radiological sabotage that you were focused on. And that was sort of the nature of the beast, and it was robust security. Obviously, September 11th has caused a lot more to be done, and I probably literally spend half my time on nuclear security issues. I'm not sure that's the totally best use of my time. In fact, I worry at the plants that we're not spending as much time on safety because we're spending so much time on security. And that's a diversion of resource. You only have so much energy. Management only has so much time, and if they spend it all in one area, they're not paying enough attention to the other. So that's actually an issue that we talk to our members about, that they need to make sure they're focused on safety, even though security is important. On security, we've always had comprehensive emergency and security plans. Let me comment on the second bullet up here, which is this one here about robust containments, used fuel pool, and used fuel storage containers. Nuclear plant operators, just like chemical plant operators at universities, can't shoot down airplanes. Okay? So it's the job of our government to prevent airplanes from hitting things. But that doesn't mean the public isn't worried about it, and it doesn't mean that people in our industry weren't worried about airplanes after September 11th. What we did at NEI was we commissioned a study from the Electric Power Research Institute to look at 767s hitting nuclear plants. And they went out and they hired the experts that do that. They spent about just over $1 million. I think it was $1.1 million. And they looked at a 767 flying at the same speed as what the plane that hit the Pentagon, hitting the containment structure. We didn't hit every type of containment. We hit typical containments, where it was determined to be most vulnerable, hitting spent fuel pool areas where we thought they would be most vulnerable, and hitting on-site spent fuel casts where we thought they'd be most vulnerable. What we found was we got no radiological release. It's a very bad day at the plant. A lot of people would die. The asset would not be very good, but we got no radiological release. And that's because the containments are really very robust. On spent fuel pools, what we found was while you could hit it, one of the things that happened was the liners, the amount of concrete in the stainless steel liner actually prevented you from getting anything released. When you hit the dry cast storage on site, you knock them over. You don't want to use a bowling analogy, but that's what you did. They were able to absorb the impact because they went with it. So looking at where radiological inventory was, we found that airplanes could not really cause a release. Now, that doesn't mean airplanes aren't a problem for any industrial facility, but it's not something that we're going to be able to deal with, and it's something we talk to the government about. They need to deal with airplanes at the source or in the air, but preferably prior to them getting in the air. One of the other things that helps us a lot at our plants is you do have redundant and diverse, and for those that don't know what we mean, we have more than one system to handle any kind of safety issue we have, so we have redundant systems, and diverse means if I have a pump that's operated by electricity, I may have another one that's operated by steam, so that if I lose electricity, my steam pump might work. If I lose my steam, my electricity pump might work. So we try and avoid single failures at our plants, and it helps us even in security. One of the things we have that no other industrial facilities in our country has, and not in other countries either really, is we have a regulator that regulates security. The Nuclear Regulatory Commission regulates nuclear power plants for security. So they have given us what they call a design basis threat, which we can't talk about. It involves things like vehicle bombs. It involves things like the bad guys attacking the plant. And you basically have to demonstrate to the NRC that you can deal with that you actually have the resources to deal with it, you have the strategy to deal with it, you have the physical infrastructure to deal with it. The picture that you see right now just shows some stuff that goes on in a nuclear plant. I'll emphasize again that security is really important. Security can impede operations. The more fences I put up, the more doors I bar to prevent people from getting in, the more difficult it is for operators to get in. And that's an important trade-off that we need to discuss. I was at the Nuclear Regulatory Commission last night, one of my 50% times on security, and we discussed the fact that we needed to keep safety and operator action in mind as we looked at some of the things we're doing, because it's got a higher probability of being necessary than a security threat. Though security is on everybody's mind right now, and rightfully so. A lot has happened, and you can read the slide. Let me just highlight a few things. We started off with the best secure facilities in our country commercially, no question. Nobody's questioned that. Tom Ridge has said that. The more he's learned about it, he said it publicly. The Center for Strategic and International Studies did a big study and concluded that nuclear plants were the most robust structures. The Progressive Policy Institute, which is the Democratic Leadership Council's policy arm, gave nuclear plant security an A, the only thing that got an A last year in their Homeland Security report card. And it's because you have all these things here. With that, we will, by the end of this year, have spent another $1 billion on security at our plants. $1 billion. We will have added about 2,000 additional security officers. We had about 5,000. We'll have over 7,000. So we have bulked it up more, and we're still spending money on it. And the problem we need to address is making sure we're spending it the correct way, getting the best bang for the buck on it. The last thing I'd say on security is there's nothing you can do at an industrial facility by yourself to deal with groups that are as determined as some of the terrorists we're talking about. So you got to have an integrated response. And the government is working on an integrated response. They've just basically exercised an integrated response program at the Calvert Cliffs nuclear plant. They're going to do it at a few others. What it's attempting to do is to see how you would bring all the assets of the federal government that you needed, local and state governments, and the commercial sector to work together to deal with any sort of security event at a facility or threat at a facility. And that's good for our country, that we kind of figure that out and get it together. Let me turn to the environmental side real quickly. What this picture shows you is that nuclear represents just over 3/4 of our non-emitting electricity source in our country. It's our second largest source of electricity. It's 3/4 of our non-emitting. The other guys that don't emit are hydro, solar, and wind. Okay, everybody else emits something. Gas plants emit pollutants. Okay, now, for full disclosure, nuclear plants emit something. We test our emergency diesels, so periodically we emit something from diesels. We do emit minuscule amounts of radiation as part of normal operation, well below regulatory limits, and less than you get from a coal plant. Actually, less than you get from drilling for oil. Okay, because uranium exists naturally. It exists in coal products. So we do emit that, but fundamentally on criteria pollutants under the Clean Air Act, we really don't emit anything, and we certainly don't emit carbon. So it's really a big benefit. From any standpoint, it helps us politically. It's something that allows people in Congress who may not have a lot of reason to support nuclear to support it, because they see the environmental benefit. Let me correct a number on this slide for those of you. This number here is a cumulative number. It really should be 189 million metric tons of carbon in a given year. And that's at carbon, not of CO2. The thing on the numbers on this slide that I think are important is you look at the number like for SO2 in a given year, the 96,000 megawatts or so of nuclear capacity avoids the emission of almost 3.4 million metric tons. The Clean Air Act, passed in 1990, basically set a goal for 10 years later of saying that we would reduce our emissions by 5 million tons per year. Nuclear plants do almost that every year by themselves. Same thing with NOx. We're doing 1.4 million tons per year of avoided NOx emissions. The Clean Air Act had asked the fossil guys to get reductions down to 2 million tons per year. So nuclear is a major player in not only helping keep the air cleaner, but it actually helps fossil generators meet compliance requirements sometimes, because we reduce the burden for them because there isn't as much for them to deal with. Now, in Tennessee, ozone is a big deal, and I testified before Senator Alexander 2 weeks ago where he talked about the TVA activities, and he talked about new plants. And the thing that really intrigued him was nuclear's avoided emissions. His question to Glenn McCullough, the chairman of TVA, was, why aren't you building more nuclear plants in Tennessee? Because then you wouldn't have all these air pollution and you wouldn't be messing up the Smokies. So it's interesting when you get senators that are actually looking at that as a major reason for going forward with nuclear. In carbon space, nuclear plants have represented, we have a voluntary carbon reduction program in our country. Okay, eventually maybe something gets mandatory, but right now it's voluntary. So you're reporting to the government, whether you're industry, whether you're power plants, what you did that reduced carbon emissions in your operations. Nuclear plants represent 40%, just over 40% of all the carbon reductions documented in the voluntary program. This is not just for the electricity sector. This is for the entire country's industrial base. So it is a major player in any program to reduce carbon. And I think that's one of the long-term things that people are looking at overall. Let me turn now to used fuel management. I think everybody that's involved with nuclear engineering or maybe listening to webcast understands that at a nuclear plant, all of our waste is solid. We don't have, used nuclear fuel is not a liquid, it's a solid. Okay, it doesn't spew out. It's all managed so that you know where it is and you control it. What you hear is that the government is responsible for taking the waste and disposing of it. Well, that's true. Because when we started our program in our country, the government thought we would reprocess the used fuel, get the energy out of it that's still there in uranium and plutonium, and then use that. So they wanted to maintain control over it so that they could control the reprocessing, because plutonium can be used in weapons. And that was the philosophy that we had until the mid-'70s, when for a number of reasons, the country decided we wouldn't reprocess. The government has always maintained that responsibility, and in 1983, they passed a law called the Nuclear Waste Policy Act. It did a couple of things. One, it made everybody in this room that lives in Tennessee at least, and I live in Virginia, so I do it too, if you get electricity from a nuclear power plant, you're paying 1/10 of a cent per kilowatt hour into what's called the Nuclear Waste Fund. So every year, about $750 million gets sent from utilities to the government for the Nuclear Waste Fund. Since 1983, that number has accumulated to be about $20 billion, with some interest thrown in, of which they've spent about $7 or $8 billion looking for disposal sites. Okay, so one of the things nuclear plants do, to be honest, that none of our other electric generation does, we've internalized all of the costs for it. Our waste costs are internalized because we're paying for it. We put away money for decommissioning for that, and obviously you pay for everything you're doing normally. So all the externality costs for a nuclear plant are actually internalized right now in the cost of electricity from that plant. So in 1983, Congress passed a law. In 1987, after 4 years of review, they decided that you ought to move the waste, or at least move the review, for where you want to put it, to Yucca Mountain in Nevada. And I'll come back to Yucca in a minute. But I think what's important to recognize here is that managing used nuclear fuel on-site, in transportation, or wherever it goes for ultimate disposal is a responsibility the industry assumes no matter who has it. Because if anything happens that causes anybody to get hurt, we're going to have the responsibility. It's going to hurt us. So we're very cognizant, whether DOE has the responsibility for final disposal or not, that it be done right. Okay, it's not that it's off our hands, we don't care, because you hear that sometimes. All you want to do is get it off your site. Yeah, that's true. That doesn't mean you want to get it off your site unsafe. You want to get it off your site and have it handled safely. That's just a picture of on-site storage. We built our plants to put the used fuel in what we call spent fuel pools, which are water. Because DOE has not been able to meet its obligation in taking the used fuel in 1998, plants have had to build on-site storage because they filled up their pools. That's what it looks like. It's not easy to walk off with. This is a person. I think he's not trying to lift it. You can also tell that obviously from a radiation standpoint, it's not very hazardous while it's in those casks since he's standing right next to it. This is Yucca Mountain, in case you thought it was the moon or Mars. Yucca Mountain's in Nevada. It adjoins the Nevada test site where our country set off a few hundred nuclear explosives. The reason Yucca Mountain came out to be the choice, Nevadans would tell you, is because they didn't have enough political clout. There's probably real truth to that. But it came out to be the choice, too, because after the 4 years of study, Yucca Mountain was the top site that the Department of Energy had identified for potential disposal of nuclear waste. And it's because of the geology. What all scientists have decided is that you should put waste in a geologic repository. That's the best place to put it. Now, it's real hard for me, and I think it's real hard for humans, to think in geologic terms, because we think in terms of how long we live. We may think in terms of the pyramids, but you don't think in terms of hundreds of thousands of years. Well, that's how geology thinks. So that's why the scientists wanted to go there, because it's stable for hundreds of thousands of years. In the event, this is surface facilities. Yucca Mountain itself, it would be buried about 1,000 feet above the groundwater table and about 1,000 feet below the top of the mountain, if you put it in there. Right now, where we are is there's studies going on there, and the Department of Energy is preparing to file a license application the end of this year. They're supposed to file it in December. If everything cranked like it should and everything turned out to be right, they could get a license from the NRC probably in the 2007 timeframe, and then conceivably start to operate the facility in the 2010 or so timeframe. That takes a lot of things to happen right, but we'll see. Let me touch real quickly on the generation. I know Dan Kiter talked about this a lot. The reason you build more nuclear plants is you need more electricity. Otherwise, you won't build them. Okay? And nuclear isn't the only way of supplying electricity. So decision makers look at other options. The one thing we know is that we will need more electricity. Okay? Our economy grows. Old plants have to get retired. And we eat a lot of electricity in this country. We actually like electricity. We take it for granted. Just a funny story, we've done a number of focus groups on electricity. And the last focus group we did on that, when you asked them where it came from, the two most dominant answers were the outlet and the switch, okay, which is certainly true in your house. But they didn't realize it came from power plants. And when they did, after you talked to them for a while, it was hydro. They thought it came from hydro, because that sounded more benign than anything else, certainly not coal. So it's very interesting. I mean, we take electricity for granted. It's like air. It's always there. The one good thing from our standpoint is that there's going to be, between now and 2025, 350 to 400,000 megawatts of new generation required. NEI 2 years ago put out Vision 2020. And we proposed that nuclear power plants, new ones should be built to add about 50,000 megawatts to the grid by 2020. Okay, we won't make that. But the logic to that was interesting, because what we did was we said, if all you wanted to do was keep the percent of non-emitting generation the same, given the growth in electricity, and if you did real robust renewables and realistically looked at hydro, which you can't do too much with, you would have to add 50,000 megawatts just to keep us at 31% non-emitting generation in our portfolio. Okay, so if you're concerned about clean air and you're concerned about the environment, you need to figure out how to do things, and this includes the conservation and efficiency that the EIA and others were thinking you could do. Okay, it doesn't assume you just go and do whatever you want. You're going to have to build non-emitting sources, and solar and wind don't get you there. They just cannot, by themselves, take you where you want to go. They can contribute, but they can't get you there. I know Dan Kiter probably talked a bit about new plants, so let me just very quickly tell you what's going on. In 1992, the Congress passed the Energy Policy Act. It created a streamlined licensing process. It streamlined the licensing process for new plants in a couple of really significant ways. It allows you to bank sites. I can go out and get NRC to review a site before I want to put a plant on it. They do all the environmental reviews, they hold public hearings, and they make a determination that either for the reactor I think I might build or for some envelope of parameters, this site is acceptable environmentally, okay, and you can bank it. They also allowed you to get what they call certified designs for new designs. I can go to the NRC as General Electric or Westinghouse, and I can bring them a design, full design. They have to review it, hold their public hearings, do their rulemaking, and they can say that design from a safety standpoint is okay. So I now can actually have a design that's approved, and I can have a site that's approved. I can then go in, when I decide it makes sense to build, and say, I want to take that design and put it at this site. And NRC would then review it. Obviously, it's a much more streamlined review because the safety issues there are reviewed. They have to make sure it fits the site okay. There'll be some unique site characteristics, ultimate heat sink, things like that. They'll look at the environmental requirements and see if anything has changed. And they can issue what we call a combined construction and operating license. It's a good process. It allows, much better than the old one, it allows public participation up front. It makes you give the full design, which we never did before. That's why we had a lot of reviews at the back end, because you didn't have it up front. So we think it's good. What we're trying to do now in the industry is firm up those requirements because it's never been tested. And we've got 3 companies going through early site permit, Entergy, Dominion, and Exelon. Exelon and Entergy are the 2 largest nuclear operators in our country. Dominion's probably the 3rd or 4th. So you have the 3 probably biggest guys out there attempting to make sure this process works. They're not committed to building anything. They're committed to banking sites. And we think if someone's interested, when do we think we might see decisions? It's somewhere in the 2005 to 2007, probably leaning towards 2007 timeframe. And it's sort of simple to figure out. You have chaos in the electricity market right now. It's very unclear what is going to be required from a transmission standpoint. So people don't want to make business decisions when they don't know what's going to happen in transmission. You also have about 60,000 megawatts of distressed gas assets out there that companies are buying about 30 cents on the dollar. So if I have money, I don't want to build, I want to buy cheap. Okay, so I'm going to spend my money there and work off this surplus before I do anything. Also, our electricity demand has been slower because of the economy. So people are going to wait and see what happens. And what we're looking at, and it's not bad for us either, because we don't think the regulatory process is going to be all that fleshed out till probably 2005, 2006. So our goal is to have as much known by then so decision makers can make their decision and move ahead. Let me end on a couple of things that I think sometimes is misconstrued. The American public doesn't think about energy often, okay? We've had people doing opinion polling since, I think, 1982. And there is not a lot of very, very deep thought by us as Americans about energy, except when gas prices go up high. Not natural gas. That doesn't affect everybody the same way. Gasoline. That really affects us. When we had a blackout on August 14th, so if there's some traumatic event, energy gets a blip. When President Bush got elected, you had the California energy crisis. When you polled then, there was a lot of concern about electricity. There was a lot of desire to build new plants everywhere. It was very prominent. The president was talking about it. The media was talking about it. But in normal routine times, they don't think about it. What we find almost consistently is strong support for nuclear energy. It's visceral. It's not deep thought. They haven't thought it through. Okay, it's a visceral. But it's counter to what I think people viscerally think people think. They think they don't support nuclear. So my message is there's a lot more support out there without a lot of information. And the more information you give people, we see a 10% point jump in support for nuclear when we tell them we don't emit greenhouse gases. Okay, so the more you tell them, the better it gets. This picture gives you an idea, and this is from October of last year. So it was after the blackout, the August 14th blackout, but not right after it, and we do forget pretty quickly. But if you look at this picture, what you see is, on visceral questions, is it important? Yeah, 71%. And again, that's not deep. There's not a lot of thought there. Same thing. Do they favor? Yeah. Now, here you're asking them more substantive questions a little bit. Should you keep the option to build nuclear plants? Well, Americans are pretty good. Options are good. Why would I throw away an option? So sure, that's an easy one. That's good. Should I definitely build nuclear plants? That's a high number. 54% of the public said yes. If you ask them whether you should renew a license, I'm not quite sure why they didn't put this on there, it's like 85%. And again, that's almost a no-brainer in my mind. Renewing a license just sounds like a smart thing to do. Why not? This is a very interesting one. A couple of years ago, I think it was right after the California crisis, we started asking a question, which I thought actually was maybe the best question we asked in this area, which was, if there was a need for more, it's a conditional probability for the mathematicians in the audience, If there was a need for more electricity in our country, would it be acceptable or unacceptable to you to build a new nuclear plant at a site where existing ones are? So it's very conditional. There's a need, I'm going to put it on an existing site. And back then we found 61 to 65% because it was right after it was in the middle of the California crisis. Very high numbers. But right now we see 57%. That's a pretty high number. Saying yes. Now why is that? Well, you told them there's a need. So they want to fill the need. You dealt with the NIMBY problem because you told them it's going where an existing plant is. If I live around an existing plant, I'm a pretty strong supporter for nuclear energy. We have our strongest support around our sites. We get into license renewal, the local population, the local politicians are very strong supporters because the people that work at the plant live in the neighborhood. They know them. They're friends, they're neighbors, they're probably family in some cases. So we have very strong support. So the people near the plants are okay. If I don't want a plant, I've already told you it's not coming to me. It's going to go to some place where there's an existing one. So in many cases, Americans are pretty rational. We have, President Bush, to be honest, has been the strongest supporter of nuclear energy we've had in the White House in 20 years. Okay. He's stronger than Ronald Reagan. He's stronger than his father. He's stronger than Bill Clinton. Bill Clinton supported nuclear energy. Bill Clinton supported license renewal. Bill Clinton supported going forward with research and development for the long-term future, not near-term. But he supported license renewal. Why? Because he saw how important the plants were to climate change. It helped him with greenhouse gas reductions. But President Bush has been the strongest supporter we've had. His decision on Yucca Mountain last year was the right decision, but it was politically courageous. The governor of Nevada is a Republican, a good friend of the president. The president still made the decision. The senator from Nevada, one of them is a Republican. The other one is the minority leader, the minority whip in the Senate, who will probably be majority or whatever if Daschle leaves and if the Democrats do it. Harry Reid's very formidable, very important to the president. So it was really pretty courageous. Now, once the president did that, we had overwhelming bipartisan support in Congress, Senate and the House, upholding the president's decision. So nuclear energy has really pretty good support in our Congress all the time. It has tremendous support in this White House over the last 4 years. Very, very positive support from this president. And it, more than words, action. Let me just end. I think the important thing I'd like to leave you with is how important nuclear plays in our electricity system. And that, again, is in a diversity of supply situation. It's our second largest source of electricity. It's our largest non-emitting source. If you really want to make our quality of life better, we're going to need more electricity. We use it. Nuclear will play in satisfying that. That doesn't mean we as an industry, we as a community, that includes the regulator, don't have to really keep focused. The worst thing we could do in our industry is get complacent. Okay, consistently you've got to strive to get better and do it smarter. And that's what we try to do. Let me end on one thing. I mentioned, the whole talk's been nuclear energy, power plants. Nuclear materials and nuclear technology really does a lot of things. Nuclear medicine, and I would suggest you get a nuclear medicine person in here to talk if you haven't, is saving lives every day. You hear about food irradiation because we talk about it and there's some controversy. Food irradiation in our country isn't all that important because we have loads of food and we waste a lot of food. Food irradiation in other countries is real important because they don't have refrigeration. So doing things with food irradiation to allow food to last longer without refrigeration saves lives. Okay? Allows people to eat who can't. The other thing that you do with nuclear materials is you do an awful lot to help agriculture improve production. The IAEA does a tremendous amount with developing countries to help them get more food production. Nuclear materials is used in all kinds of industrial applications. It's used in making sure welds are good, and you know that from radiography. It's used to fill beer cans because it's so precise, you can actually put it in the machines to make sure that the beer can is filled correctly. It's used for making asphalt is done right. There's a bunch of stuff on our web page on nuclear materials, and I'd encourage you to take a look. It's amazing how it's used. I'd encourage Lee to get a nuclear medicine person if you haven't had one. I think it would be fascinating for everybody to hear what's done in nuclear medicine. With that, I'm going to stop, and I did bring along a DVD that we've sent out pretty broadly on nuclear security. And it does probably a better job with more pictures than I could do in the slideshow, and it's not that long, so I thought what I would do at the end of this, before we got into questions, is just show the DVD, and it generates some questions. We can talk about those too. It will repeat a few things I've said, but it'll also give you a pretty good picture of a power plant and what security looks like at that. So I guess, Gary, if we could do that, we'll do it.
Okay, while he's getting the DVD going, we have time for a question. When the DVD comes on, we'll stop with the questions. Larry?
Not in the...
Let's just wait.
All across America, a vital source of clean electricity powers our economy, serving 1 of every 5 homes and businesses. Our country's nuclear power plants are by far our largest source of electricity that emits no greenhouse gases. 103 reactors at 67 sites across the country is a model for American industrial safety. They are proven performers, providing reliable power around the clock 7 days a week. Nuclear plants are the economic lifeblood of nearby towns and
I
communities.
want you to know he did this perfect in rehearsal.
That's right. We did it right before we started, just did the check. Actually, while we were started time, I wanted to do that.
All across America, a vital source of clean electricity powers our economy, serving 1 of every 5 homes.
We got it, Gary, on this part.
Our country's nuclear power plants are by far our largest source of electricity that emits no greenhouse gases. 103 reactors at 67 sites across the country serve as a model for American industrial safety. They are proven performers, providing reliable power around the clock 7 days a week. Nuclear plants are the economic lifeblood of nearby towns and communities. Highly trained professionals, most of whom live in these communities, operate these essential facilities. Safety and security have always been the industry's top priority, since the first commercial nuclear plants began operating some 40 years ago.
103 nuclear power plants in the United States, operating nuclear power plants in the United States today, are the best secured critical infrastructure in the country.
Protecting the reactor are multiple layers of steel and concrete. This approach of layered backup systems is typical of sophisticated nuclear plant engineering, design, and operations. It is an approach that is fundamental to safety and security. Because of this approach, nuclear professionals are well prepared to address threats to the plant. Control room simulators help train operators who can respond to abnormal events to keep the plant safe, whether these events involve plant systems or an attempted terrorist attack. The plant has several backup systems and a highly trained, well-armed paramilitary security force. Plant security is subject to stringent standards set by the U.S. Nuclear Regulatory Commission, which oversees nuclear safety. The agency has issued new requirements since September 11, 2001, which the industry has implemented.
We make sure the plant is safe and secure so that badged, screened, and cleared employees can enter and do the appropriate work, and individuals that have no legitimate reason to be there are kept out.
About 7,000 trained security professionals guard our nuclear power plant sites in the United States.
Since we have a lot of officers that have military and law enforcement backgrounds, we join significant amounts of both of those elements into our training. And we train more so than local law enforcement officers. Our officers receive trained armed guards and weapons qualifications on a quarterly basis, which is more significant than local law enforcement.
They are well-trained, highly motivated professionals. Almost two-thirds have previous military, law enforcement, or security experience. From the armed forces, police forces, and the FBI, many have college degrees.
The nuclear field is a field that has structure, solid training, and this type of field attracts people with a background in military, law enforcement, and other people who like that challenging environment, that very high standards environment that also provides them with a long-term career path.
And there is a high degree of job satisfaction The job retention rate is more than 90%. When they first take their jobs, these officers undergo more than 270 hours of training. After that, they receive about 90 hours of training each year. They also engage in about 30 hours of anti-terrorist training and regularly train in mock exercises to defend the plant. The industry works closely with the Nuclear Regulatory Commission to enhance these programs.
Prior to my employment here, when I was a United States Marine, we consistently trained most similar tactics to what we have here as far as along the lines of guard duty, basic Marine Corps infantry tactics, buddy team rush, fire maneuver.
Since September 11, 2001, nuclear plants have undertaken a broad range of improvements to make their security capabilities even stronger. Because the federal government safeguards many security features from the public, the full extent of these cannot be shown here. Security forces have been increased by 33% across the industry. Plants have added new security technology, increased patrols, extended security perimeters, installed additional vehicle barriers, and moved these barriers farther from the plant, strengthened controls on site access, and improved coordination with local, state, and federal law enforcement, the National Guard, and the U.S. Coast Guard. The industry has spent more than $400 million on security through 2003 and will have spent up to $1 billion through 2004. Layer upon layer of security makes access to a nuclear plant virtually impossible for those without authorization. The first layer consists of the outer perimeter, typically barriered and patrolled. Within the perimeter is the protected area. This includes the grounds near the plant building. It is typically surrounded by a double fence topped with razor wire. Access to this area is strictly controlled. The third layer surrounds the vital area. This includes the equipment needed to shut down the reactor safely. This area is heavily guarded and is sealed off from everyone but those with specific authorization. To pass through these security layers, this is what you would encounter. First, vehicles are subject to search. An unauthorized intruder would have to penetrate concrete barriers, crash-resistant gates, and other physical barriers. Anyone entering the protected area is also subject to search. This area is closely monitored. In fact, everyone must pass through metal detectors, and many times through other electronic detection devices. To enter the plant's vital area, an individual must be authorized to perform specific duties there. Inside the vital area, the building itself is constructed of heavy steel-reinforced concrete. Individuals must pass through steel doors and other barriers. Authorized personnel must use card readers to open these doors. Security officers are strategically located throughout the plant site.
We're held to a higher standard by the Nuclear Regulatory Commission. We believe and support that standard. We implement security and take it very seriously at the hard stations that we are.
An officer's ongoing training sharpens the industry's ability to respond to intruders. The plant's ability to withstand greater threats also has been proven. State-of-the-art engineering studies have confirmed that major plant structures, the containment building and fuel storage structures, would not be breached by a wide-body aircraft. Regulations and new security approaches continue to evolve for our country as we establish a comprehensive homeland defense capability. An integrated approach, maximizing our resources, is now critical.
Nuclear security should be the role model, should be the standard of security in America.
I think the average American should know about the nuclear security program, that it is safe, and we have appropriate measures in place to protect the immediate public.
The most gratifying part of my job is the fact that I get to help shape the defensive strategy, which helps protect the plant and the general public.
Nuclear power plants were safe and secure before the September 11th attacks. They're even more secure today.
Okay, we have time for one question, possibly two. Larry?
Okay, on the reduction of greenhouse gases and so on, the Kyoto courts don't recognize nuclear, at least they did, the originals did not recognize nuclear as reducing greenhouse gases. Is that ever going to get rectified, and so you count it even if you do it?
Well, it doesn't appear Kyoto is going anyway right now. I mean, the Russians are not signing on, the U.S. isn't signing on. So Kyoto as designed, the reason Kyoto does not recognize nuclear is that it's driven by the Green parties in most of the European countries. And if you went over to any of the Kyoto meetings that went on, you would have found that's what was going on. Nuclear, it wasn't, I shouldn't say this. I think they do want to reduce greenhouse gases, but they don't want to do it and support anything that they ideologically were against. So I think that it would have been very difficult. Now, the U.S. would have still implemented the way the U.S. was going to implement. So I wouldn't expect Kyoto would have changed, Larry, but I think Kyoto itself is going to take a whole different role because it's no longer really viable the way they were going without the Russians signing on to us.
Okay. As everyone knows, I don't think we have any new faces here in the audience, so everyone knows that we do have a reception downstairs, and Marvin will be available to answer more questions. But before we adjourn, let's express our appreciation again to Marvin for his presentation.
There's copy material here for the folks in the room. On careers, on the presentation, even.
All right. No, I bet I know about it.
It sounds like this. That's right. It took you 2 minutes when you came here and the pastor there. You had to enter your name.
Oh, it's good.
On your count.
Yeah.
I bet I didn't.